In this video I'll attempt to show you how the gear change and synchronization handshaking work. But first let's have a quick look at the wiring of this back of the Heidenhain TNC155. It's a little bit of a mess, but it's a lot better than it was before I got it. The problem is that all these cables here have different types of cores, different diameters and so on, and by the time you get up to the back plane here on the TNC155 it looks pretty messy. It's actually not as fierce as it looks. This whole back plane here is optically isolated, so it's floating, and so is the input and output to the little Izumi PLC that does the gear changing and now the star delta timing for the motor start. So the advantage of it having it all floating is that you can interconnect everything without any worry about short-circuiting. So the wiring from this backplane goes hardwired to the floating backplane of the Izumi PLC, and the Maho supplies a separate 24 volts for that backplane. The other thing to understand is that all of the outputs on this backplane are momentary outputs. So if they talk to a relay, then you have to have a self-latching system on the relay. So some of the M codes, the motor start and stop, coolant off and on, are actually hardwired directly to relays which have latching. As a result, they have to have another M code to unlatch that relay. So we have a situation where there are hardwirings, but also where there is the ability to put up a byte on the backplane that it can be interpreted in many different ways. This implementation on my machine uses both the hardwired contacts on the backplane here and a set of coded ones, 1 byte of coded ones. And the advantage of setting the coded ones is that you can tell the Izumi PLC to run an auxiliary program, and when it's finished it will send back a handshake telling the TNC that the auxiliary function is finished and now it can proceed with machining. One area of interest is that it has the ability to put out coded inputs on terminals J2 to J2 9, 8 bits. You can use it for multiple different things, and depending on what you want to do, it has 3 strobes down here, an S and a T and an M strobe. Those are for the speed, the tool selection and the various M codes. So the Heidenhain can put various 8 bits here, and depending what's required, it actually strobes them in on either the S or the T or the M strobe. These 8 bits are actually hardwired to the Izumi PLC that does the gear change and now the delays on the star delta start. And depending which of these strobes goes off, it depends on how the receiving Izumi interprets them. Of course, if I happen to have a tool changer or some other device, those same 8 bits could be hardwired to that as well, and then these strobes would select which particular device was going to read the information of these 8 bits. Here we're looking at the Izumi PLC, And you can see here those same 8 wires that were wired to the backplane of the Heidenhain TNC155 come in here, and you'll notice I've labelled them the same as the backplane of the TNC155. Also, you'll see here the label of the M strobe and the S strobe on the Heidenhain TNC155. So the Heidenhain will put up 8 bits here, and as soon as it's done that, it'll decide whether it should put up an M strobe or an S strobe. If it's an S strobe, the program in here will operate these 3 motors here in succession, which are on the 3 selectors, gear selectors on the gearbox, and it will look at these cams here from selector 1, selector 2 and selector 3, and the one that has a light out here actually is an open switch on one of the cams, tells you which one is actually which gear it's in. If the TNC puts up a different set of data here for a motor start, it will be strobed in by the M strobe, in which case another program in here will look at these cams to decide which gears the gearbox is in, and put an appropriate timer up for the inertia that the gearbox has. Obviously, a higher inertia takes more start time, and when the start timer has timed out, and in case previously the S strobe had timed out, when either of those programs is finished, it sends back to J57 on the TNC155 that either of those auxiliary functions has finished, and then the TNC155 will proceed with whatever programming it's doing. I think I'll leave it there. In the next video I hope to show you all the lights flashing and so on as it does both of those types of coding all at once.